Okay, welcome back everyone. It's Professor Sebastian. These are our Calculus 3 class notes. And we are moving on to the next page where we're going to talk about example 41, 42, and 43. We are on page 48. Okay, so we just got done explaining what the partial derivative of a function with respect to x and the partial derivative of a function with respect to y is on the previous two pages. Del f by del x, or partial f with respect to x, partial f with respect to y. That's typically how I like to say it. Sometimes just saying del f just gets tiresome. So I will typically say partial of f with respect to x, partial of f with respect to y. And then we want to evaluate it at a specific point. Okay, but first we'll find partial of f with respect to x. So this is our function. Now remember, this is the slope of the tangent line in a direction that is parallel to the x-axis or perpendicular to the y-axis. That means y, it's always y is some constant there. Y does never change when I'm looking at a line, the slope of a line that's perpendicular to the y-axis. So the way you think about how to do this mechanically is you think about, well, if I'm going to take the derivative of f with respect to x, in this case the partial derivative of f with respect to x because it's a function of two variables, x and y, then I want to take the derivative with respect to x, and just anywhere I see a y, just treat it like it's any other constant. Like treat this 3xy as just some constant times x, right? 3 is a constant and y is a constant. So think of 3y as just a constant times x. So for example, if I'm going to take the partial with respect to x of the function, so that's x squared. So I just take the derivative of x squared as though I was in Calc 1 taking the derivative of x squared as the power rule. I get 2x. Now, the derivative of 3 times x times y. You treat 3 as a constant, which it is, and y as a constant when I'm taking the partial derivative with respect to x. So the derivative of any constant times x is just that constant, right? So the derivative of 3xy is just going to be 3y. The derivative of y, now you treat y as a constant because I'm taking the partial with respect to x. So the derivative of y is just 0, and the derivative of the constant minus 1 is just 0 when I'm talking about taking the partial with respect to x. So I end up with 2x plus 3y, and then if I want to evaluate it at the point 4 minus 5, I plug in 4 for x and minus 5 for y, and I get minus 7. Similarly, if I want the partial of f with respect to y, now I treat the x's, any x's I see, as a constant also, in addition to any constants I see. So the partial derivative of x squared with respect to y, there are no y's, so x squared is like a constant. So the derivative of a constant is 0, so the derivative of x squared is 0. The derivative of 3xy, now I'm taking the partial with respect to y, that means I treat x's as though they're constants. So 3x is a constant, so that's a constant times y. So the derivative of a constant times y is the constant, so that's just 3x. The derivative with respect to y of y is just 1. And the derivative of minus 1, a constant, is 0. So I get 3x plus 1. Evaluate at the point 4 minus 5, I get 3 times 4 plus 1 is 13. Okay, so just trying to remind you that the rules will always work like they did back in Calc when you first learned these rules. So here I have a function of x and y, which is y times the sine of x times y. So now when I want to take the partial of f with respect to x, that means you take the derivative of this guy treating y's as though they're constants. So when I have a y in front, I just leave it there alone. It's a constant times the sine of xy, treating y as a constant. So I got to use the chain rule on this. The derivative of the sine function is the cosine function, leaving the inside alone, leave x times y alone. But then I have to multiply it times the derivative of x times y, right? Remember the chain rule? Okay, so when I multiply times the derivative of x times y, but I'm taking the partial with respect to x, that means I treat y as a constant. So the derivative with respect to x, the partial derivative with respect to x of xy is just y. So that's that y sitting there. So now when I simplify, I have y times y is y squared cosine of xy. Similarly, if I want the partial derivative of f with respect to y, I treat the x's as though they're constants. So now I have to use a product rule because I have a function of y, which is just y, times another function of y, sine of xy, treating the x's as a constant, treating that x as a constant. So I have to go first y times the derivative of the second. So times the derivative of sine of xy is cosine of xy times the derivative of the inside Now the derivative of the inside, I'm taking the partial with respect to y, so you treat x as a constant, so it's just x. So that's that x right there. So that's first times the derivative of the second, plus the derivative of the first, which is the derivative of y. Partial derivative of y with respect to y is just 1 times sine of xy the second. So I get x times y cosine of xy plus sine xy. Okay, and then to also remind you about the quotient rule, here I have a function of xy, which is as a quotient. We have a rational function, 2y over y plus cosine x. So when I take the partial with respect to x, right, it says find f sub x. That means take the partial with respect to x of this. I treat y as a constant, but I'm going to use the quotient rule. So low, y plus cosine x, d high is partial with respect to x of 2y. But 2y is a constant because I'm treating all my y's as constant. So the derivative of any constant is 0. So that's gone. So something times 0 is 0. Minus, so low d high, minus high, so 2y. By the way, notice I'm trying to be really careful because I know when I'm going fast, my del's look like my 2's. So I'm trying to put a good loop in my 2's. But sometimes you have to, you might see my notes and not see it as nicely as I do. But okay, so anyways, back to the quotient rule. Minus high d low. So high is 2y. The low is the partial with respect to x of y plus cosine x. So the partial of y is 0 because y is like a constant. And the partial with respect to x of cosine x, well, there is no y, so you just take the derivative with respect to x, and that's minus sine x. So in the numerator, I get minus 2y times minus sine x because the left-hand side is 0. Then the denominator is just the denominator squared like it is for our regular quotient rule. So that simplifies to 2y sine x over y plus cosine x squared. And then if I want the partial of f with respect to y, I treat my x's as constants, still using the quotient rule, so low, d high. Now the derivative with respect to y, the partial with respect to y of 2y is 2, so that's the 2 right here, minus high, so 2y, times d low. Partial with respect to y of the bottom, partial of y with respect to y of y is 1. Partial with respect to y of cosine x is 0 because you treat x as a constant. So like that cosine of a number is just a number. So partial with respect to y of cosine of x is 0. So you just get 1 for this derivative. Divided by the bottom squared again. So 2 times y plus cosine x minus 2y. So that's 2y plus 2 cosine x minus 2y. Those 2 y's cancel. And I just end up with 2 cosine x over the bottom squared, which is y plus cosine of x squared.